It's time to do some level 2 examples. So in number 2, we're asked to find the middle term of this binomial expansion. So the first thing I want us to figure out is which term number we're looking for. Remember that when we're looking at an exponent of 6, this does not mean that we have 6 terms in the expansion. Rather, this means we have 7 terms in the expansion. Always one more than this exponent. If you forget that ever, just think back to when you FOIL, right? If something is squared, we expect 3 terms, always one more. Therefore, we should expect 7 terms in this expansion. So what is the middle term in 7 terms? Some people have a hard time with this, so I'm going to write it out. So what's in the middle of this set of numbers? You got it, it's 4. So we are looking for the 4th term. We are looking for T4. So in our 4th term, K is 3. You got it. So if K is 3, and remember, this guy is always our N, then we have just about all we need to plug this in. So we have 6C3. Now, this part is a little bit new. Normally, I would just write A to the power of n minus k. But what is our A right now? It's not A, it's 2A. So instead of thinking about it as A, I want you to start thinking about it as a blob, because it doesn't matter what it is. It could be 2A. Look, in the next example, it's 3x. Doesn't matter what it is, it's going to be to the power of 6 minus 3. So in this case, it's 2A all to the power of 6 minus 3. And then B, oh, except it's not B this time. Is it 5 or is it negative 5? That's right, it's negative 5 to the power of K, which is 3. So one more time. This is 2A because that's 2A. This is negative 5 because that's negative 5. Whoa, it went really dark for some reason. It's not A and B the way it was before, because not every example is going to have A and B. Now we're ready to evaluate. 6C3 on your calc, 20. Then I have 2A all to the power of 3. So that means that I'm cubing all of 2A. So 2 cubed is 8. And then I also have A cubed. Okay? And then negative 5 cubed will be negative 125. I can put it all together. I'll get negative 20,000 A cubed. Pause that, try it again before we go on to the next one. And the next one, we are asked to expand 3x minus 2 all cubed. So now we're going to need to put together what we know about the exponents with what we know about what happens to our A and our B, or in this case, our 3x and our negative 2. So first of all, if my exponent is 3, that means I'm looking at the 4th row in Pascal's triangle. So I'm going to draw a little triangle up here. This would be to the power of 0, right? We would just have 1. Then we have 1, 1, then 1, 2, 1, then 1, 3, 3, 1. So the 1, 3, 3, 1 will give us our coefficients that we can use. 1, 3, 3, well, I should actually spread this out even more. 1, 3, 3, 1. Alternatively, you could use the general term for each term in this expansion, right? We should expect to have 4, or you can do it this way. Either way is up to you. So now we know that now that this coefficient is 1, right here I'm going to have A to the power of n, or 3x, which represents my A, to the power of 3, and negative 2 to the power of nothing, which is why it's not going to appear. Then I have 3x squared. That looks like bx because of journal. Holy smokes, journal. There we go. Then I'm going to have 3x to the power of 1, and then 3x to the power of nothing, right? This is exactly what we were doing before with A and B, except now A and B are going to take on more realistic values. Okay, our b is -2. So here we will have no b's. Here I'll have -2 to the power of 1. Here I'll have -2 squared. And here I'll have -2 cubed. Add them all up. And now I'm ready to evaluate. So 3 cubed is 27. 27x cubed plus, I have 3 times 3 squared, so 3 times 9 is 27 times -2 is -54. Should be subtracting, oh well. X squared plus 3 times 3 is 9. 9 times -2 squared, which is 4, gives 36x. And then -2 cubed is -8. I'm just going to change this to a subtraction because it's going to bug me. And there we have it. It's expanded. So you have another tool in your tool belt now. You can FOIL and then multiply again, or now that you know Pascal's triangle, you have a quick way of expanding cubics and others. Let's do one more. Okay, in this question we're going to be going backwards. In this question we're given that one of the terms is this, and we need to figure out the value of A. So we need to be detectives. Let's look at what we know so far. What is this? That's right. This represents our N. So now all I know is that this is N. Let's write out what we know plugging this in for N. So we don't know what term number we have, but I know that this is 10 CK because I know that N is 10. Then I have X to the power of 10 minus, to the power of 10 minus K. And then I have A to the power of K. And I know that all of this has to be neat. There we go. I know that all of this has to work out to give me 3,281,250 x to the power of 4. Okay, there we go. So let's see if the detective in you has figured out what K has to be. I'll give you a clue. Here is the X on the left, and it has to work out to give me X to the power of 4. So what does that make K? That's right, it makes K 6, because this has to be 10 minus 6 on the left to give me 4 on the right. So then I can fill in that 6, and this is 6. And now I can figure out the numerical value of A by working this out. So 10C6 is equal to 210. Okay, on your calculator, no worries. Then I have X to the 4, A to the 6. I don't know why it does this. Oh, okay, A to the 6. That used to be highlighted. I'm going to re-highlight. There we go. So 210 was this that I evaluated. X to the 4, A to the 6 is equal to 3,281,250 X to the 4. Now you can see that on both sides I have an X to the 4, and because in this question I'm interested in the numerical value of A, I can divide both sides by X to the 4 and eliminate it from the question that I'm doing. Now, if I divide both sides by 210, I get A to the power of 6 is equal to, I hope you have your calculator ready, 15,600, oh my goodness, 15,625. And then lastly, to solve for A, I'm going to take the 6th root of 15,625, and we can get that A is plus or minus 5. Again, because if A was negative or positive, it would give us the same value of 15,625. So there we have it. We found A. If you want to challenge yourself, try number 5 before watching the video. I will give you a clue. The constant term is a term that has no variables. So how does that make sense if there's a variable and a variable? Give it a try.